Okay, I had a YouTube viewer send me this problem in, and I thought it was an interesting problem to do. He was wondering, even though he was watching a linear programming video that I have where we're finding the minimum. This is in fact not linear because this is a parabola, and a parabola is a curve, so this is not linear programming, but we can still use Excel to find the solution to this rather than using calculus. Although calculus wouldn't be too hard to do, but it's kind of fun just to see if we can use the power Excel to solve this. So we have two curves. We have a line and we have a parabola, and they're not touching each other. And I'll show you here what's going on. We could plot this. We could go at each x. We want to find the y for the line, and we want to plot the y for the parabola. Okay, and in order to plot this, let's just start at x of a -2, and then we'll go by, let's say 1/10, and we'll plot all the way from a -2 to a plus 2 on the x-axis. Okay, so I'm going to drag this down. In order to get the idea, you got to highlight two of them, and we'll drag it all the way down until it says +2. Okay. And so this is what our x-axis is going to have. It's going to start at -2, go by tenths, all the way to +2. And remember, you just do the first two, highlight them and drag it down, and Excel has intelligence built in, and it'll do the rest for you. And then for the line, we know if x is a -2, the line is equal to x minus 1, so it's equal to this minus 1. Okay, and we can just double click here and copy that all the way down. And for the parabola, it's equal to the x, and we have to square it because that's what we have here. Y equals x squared, so we're going to take this and square it. And -2 squared is 4, so that makes sense. We'll copy that all down. And negative is 1 squared, and negative times a negative is a positive, so 1 times 1 is a positive 1. That seems to be correct. So now what I'm going to do is I'm just going to highlight all this. And you can go, let's just highlight it manually. I'm going to show you a shortcut, but let's just highlight it manually. And then we're going to go insert. And probably the easiest way to graph this is to do a scatter plot. And I'll do the one with, you can have several choices. You can do just the dots, just the points with a curve, the points with a curve. We can do the different things. I like this one right here. This actually looks better for this. Okay, and I'm going to move this over here and drag it. Now I'm going to get rid of the title because we kind of know what this is. And I want the scale to be the same in the X and the Y. So I'm going to click on this axis and right click. I'm going to go Format Axis. And I know my numbers are from a -2 to a 2. So I'm going to say the minimum is a -2 and the maximum is a 2. Okay. And then I'm going to close that. I'm going to click on this axis. I'm going to format the axis. I'm going to make the same. I'm going to take the minimum, a -2, and the maximum, a 2. And now we kind of have it to scale. The only thing you might want to do now is I'm going to drag this kind of up here so I have more space, and then drag this down. And I want these to be approximately square, all right? So I'm going to drag this. If I have these looking square, then I know I'm more to scale. So those approximately look like squares, and I have this 2 and 2. So now I kind of see more what's going on. So the line is here, right? And then it crosses through the y-axis of the -1. That's what we say. The slope is 1 because the rise over the run, this is 1. Anywhere I go, it goes up 1 and over 1, right? So the rise over the run, 1 divided by 1 is 1. So we know the slope is 1. And we know this is a parabola passing to the origin at 0, 0. So we kind of see what's going on. And you can probably look here and kind of see where the minimum is. The minimum is going to be right about here, right? And it'll probably be perpendicular to this line. We could go here and go Insert. And I'm going to insert a shape. Let's insert, I don't know, let's insert a little octagon, right? And you know the minimum's right about here. Okay. And then the other one, let me copy this. You can insert any shape. I decided to do an octagon. And let me go over here. Let me try to get insert, shapes, do another octagon. And it's probably right about here. Right? Maybe that wasn't a really good shape to do. So that's probably where the two minimums, you know, and then if we draw a line, so I'm going to insert another shape, insert a line, and you can see that the minimum is probably going to be a perpendicular. You know, if you made a perpendicular line to this line and pass it through where the tangent point to this is, where the tangent point is, the slope of the tangent point on this curve is parallel, so the slopes would have to be the same. And if you constructed a line through that point coming perpendicular to this, that would be the minimum distance. So you could do that with calculus, right? You could say, you could take the derivative of this to find the instantaneous slope at each x. So the derivative of this would be 2x. And you know the slope of this is 1, right? And you say 2x equals 1. You solve for x would be 0.5. And that looks like about where we're at. X is at 0.5. So where x at 0.5 would be where the slope would be 1, and then you could actually solve this, plug that 0.5 back into here into the original equation. 0.5 squared would be 0.25, and that's where the y is. So this point is actually using calculus. This point would be at 0.5, 0.25, and then you could, you know, the line going through this would be perpendicular to this would be the m of a minus 1. So you know this, and then you could anyway, you could solve this and find this out. And actually I did that using calculus, and I'm not going to go through how to do it totally, but I solved it using calculus, and I found out that, whoops, let me control Z that, because the distance between those 2 points is 0.5303. Now I'm going to show you the easy way to do it using Excel, because that's what this problem is all about. But anyway, it's kind of interesting to plot it and see what's going on. So really you could do this without plotting and without doing any of this. What you could do is you could say, now understand that the y and the x are not going to be the same on these 2 points, because the two curves don't intersect, right? So you could say x of the line and y, you want to say x of the parabola and y of the line and y of the parabola. Okay, so we could put these here, and we could just arbitrarily say this is like 2 and 2. We don't know what these are. These are the inputs. We know the y of the line is equal to the x of the line minus 1, just like we did over here, right? And the y of the parabola is equal to the x of the parabola squared, right? Because that's what we have right here. So as I change this, if I change this to 3, 3, then these will change. So if these are my inputs, these are my outputs. So I could actually vary these. If I vary these inputs, these outputs are going to change, and the x, y coordinate and the x, y coordinates of these, as we vary these, the distance apart of each one of those is going to change, and we want to find the minimum. So in order to find the minimum, we could use the Pythagorean theorem. And we know that that's equal to the square root of 2 parentheses, this minus this squared, all right, plus this minus this, put that in parentheses, and also square that and close the parentheses, right? So it'd be the square root of the two, the difference of the two x's squared plus the difference of the two y's squared, and that would give you the hypotenuse, right? So we're finding this distance squared, this distance squared, adding them together and finding the square root, right? And just by varying this, okay, so at these 2 points we know this is a 7. So what we're going to do, we want to vary these until we find a minimum, this to be a minimum. Now, the nice thing is Excel will do this automatically, okay? And what you're going to do, you're going to go to Data, and you're going to go to Solver. Now, you may not have Solver. Solver doesn't show up unless you install it. So when you first install Excel, it won't be there. So you have to make it show up. Once you make it show up on your Excel, it'll stay there, but you have to make it show up. And the way you do that, and if you don't have it here under the Data tab, so you go to Data, and you look under Analysis. If you don't see Solver, you're going to have to go to File, Options, and then you go, after you go to File Options, you're going to go to Add-ins. Okay, and then down to Excel Add-ins, you're going to go. And you have to make sure that if your Solver is not showing here, this is not going to be checked. You have to check this. And then you click OK, and it'll show up here. I'm going to hit Cancel because I already have it there. But you check this and hit OK, and in a few seconds, Solver will show up there. Once you have Solver, you're going to click on this. And it says Set Objective. We want to. This is my objective right here. Okay? And I want to set that to a minimum, right? Because the problem is we want to know the minimum distance between the line and the parabola. And we want to change these two inputs. Remember, these are this is an output and this is an intermediate output. These are my inputs. So I want to change these, which will in turn change these, which will in turn give us this, and we want to minimize this. So that's why I have this as I want to minimize this by changing this. I don't need to worry about these intermediate outputs. Okay, leave this on GRG nonlinear. You don't really need to do this non-negative variables. You can uncheck that. I don't think that'll make a difference in this case. You can't use these other two because these are linear, and in our case this is non-linear because we have a parabola, right, which is not linear. Then we're going to click Solve, and I'm going to go OK. If you remember right, it was 0.5303. Now one thing you might want to notice, so let's solved it, but we might want to take this, you know, Excel has a little bit of rounding error, so I'm going to highlight all these and go to the Home. I'm going to take them down a couple places, and it gives you more of an exact looking answer. So these are more, you know, if you round it up, this is basically the exact answer, 0.875, 0.5, negative 0.125. So then we can check it by looking over here, 0.875 and negative 0.125 for the line. Well, that looks like that's about that where that's at, right? Negative 0.125, 0.875, and 0.5 and 0.25 for the parabola. And we said we found that already using calculus, right? And the distance between these two appears to be a little over half. If you look at one of these squares as a half, so it is a little bit over half. So our answer looks reasonable, so that's the answer. Okay. So I thought that was a very interesting problem. I was glad that YouTube video sent this to me. Although this is not a linear program, you can still use Solver and find this without using any calculus. Now also what's interesting, I could make this line pass through 0, right, where it's actually intersecting. Okay, so if I made this y equals x, and we make this y equals x, then that line is going to come up here. I'm going to get rid of these. These go away, all right? So now the line moves up here. We have to change this to y equals x also. Okay, and now what we can do, we can go ahead and solve this again. So I can go to Data, Solver, Solve, and it finds this point here, 1, 1, and it finds that the distance is 0. Of course, since they intersect, the minimum distance is 0. You can see there's another solution here too. So maybe if I would have started down here at a minus 1 for the x. See if I started at minus 1. Oop, I guess I hit number locks by mistake. Minus 1 and maybe minus 1. So I start down here. I wonder if I can get the solver to zoom in on this one. Let's try it. Solve. Solve. And sure enough, it zoomed in on this point now. So depending on where you start, Solver will zoom in on, you know, since there's two solutions. The first solution I started up here, so the closest thing was here. The second one time I started over here, so it came in on this solution. But anyway, my point is, even if the lines touch, or intersect, it still finds the answer. So this is a very powerful. The only thing is sometimes there might be more than one solution. So hopefully that helped. If you like this video, make sure you click on the like. If you want to subscribe to my channel, I'd appreciate it. Just click on my picture. And thank you very much for watching. Bye.